Hi and welcome back to the channel. We're continuing to look at this build of the Peckett GAMECOCK locomotive from the short run batch kit. As you may remember, if I can see where we've got the box, so far I have a chassis with the pulley and lay shaft in, and the wheels turn nicely when you turn the pulley. Everything was assembled nicely, it's all nice and square. The next big thing in the instructions really is to build up the outside cranks that go on the ends of the axles. So this video is probably going to take place over multiple parts. Well, a single video. They'll have pauses in between it. It won't be a single take discussion like a lot of the videos on here are. Because I'm not going to try and build them on camera, but I am going to try and show you the different steps. Now, the cranks in this kit are etched, so you can see here are these 4 different panels. Now this is different to lots of kits that I've seen in the past, where you often end up with the cranks being lost wax castings, or potentially in some kits plastic parts, but I've had definitely lost wax casting ones where the screw that forms the crank pin and everything is all cast into a single piece. I think they were like this on the Canopus loco. I'll stick a link up to Canopus here if you haven't seen that video. And they can be of variable quality. I mean, obviously somebody's made up a decent set of cranks to start with, but then a mold's been made, casts have been made, and obviously the molds can kind of wear over time, and sometimes you end up with cranks that it's very difficult to get square, or the hole for the axle to go through isn't quite right, or the pins are bent on the castings, or the thread doesn't work very much, so tying the screw on is difficult. These are done differently. So these are done by essentially laminating together these four panels. So you can see that they're actually they're all different, I think. So they start with, this is the bottom of the crank, then this layer, then this layer, then this is the top. And what you'll find is, if you look at the back, you can see here, if I can get the camera to show, it's a bit difficult to see, but there you go. This one has a half etch around the end of the crank where the crank pin is, but where the axle is, it's solid. So that gives a bit of clearance for the crank pin against the wheel. The next one along is just full thickness. There's no half etching. Oh yeah, in fact these two are the same. So both of these are full thickness. No, they're not. No. I'm talking rubbish again. Oh, let me get this right. So half etched on the back, so that there's a bit of relief behind the actual crank pin end where you're going to put a screw through. Then a full thickness one. Then this one's half etched on the front to give it a kind of a complete piece, but only half as thick. And then this one is half etched on the front again, but this time there's a small the around the crank pin hole is left full thickness. So that means that when you have the crank pin coming through, the coupling rod is only going to run against this little surface, not the entire crank pin, which obviously would lead to a lot of friction and things being able to kind of snag. So yeah, so the process is essentially I need to remove all these 4 panels, laminate them together, and then I believe from the instructions I have to countersink the holes in the back, so that I can put the 16BA bolts in flush at the back, so that they will rotate without catching on the wheels, and then solder that crank pin in place as well once it's and tap the hole for the 16BA so I can actually essentially screw the crank pin into the crank, which should give a nice solid connection, but then also I can heat them up slightly, and the solder between the layers should move ever so slightly enough to kind of bind that pin in place permanently, and I should have a completely solid crank. Now you'll notice there are actually 5 cranks on each of these etches, but only 4 wheels. I'm not going to have a 5-wheeled locomotive, would be weird. It's because Stewart's provided a spare. They are small, and while a lot of the assembly is done inside the frames, so you essentially laminate the frames together using the holes in the corner as guides for cocktail sticks. Obviously once you then start separating them from the etch, they are small. and easy to lose. So there's a spare provided, which is nice. I mean, it's one of those little things. It doesn't take up a huge amount of space on the edge, and there is enough spare material that went, on the corner of the sheet that we're not that short for space. But it means that if you do lose one to the carpet monster, it's not ruined the kit entirely. There is a spare, so I'm going to be careful with them. I don't want to lose any of them, but it also means if I mess one up, countersinking the hole or tapping it, then it won't be a problem. So yeah, my plan is to essentially separate these from the etch, making sure I remember which is which order, and then clean them up and laminate the cranks together. And I'm going to do the laminating with the resistance soldering unit, I think, because I should be able to tin these quite easily with the normal iron. But then when I want to actually register them together nicely, I should be able to. I mean, I might be able to do it with the normal soldering iron, but I think it'd be easier just to stick the resistance unit in the hole in each crank and work my way across and nicely put the thing together. It also means that I'm pushing down. So the nice thing about the resistance soldering unit over a normal soldering iron is obviously you push down with a normal soldering iron to get the heat in and to get it to spread between the layers. But then to get the solder to cool and solidify and hold everything in shape, you have to take the iron off. And when you take the iron off, there's a chance of things moving, but there's also a chance, that these layers kind of pop up ever so slightly as things cool or move around. So you obviously have to hold everything in place, which is tricky. But with the resistance soldering unit, of course, you're applying the pressure with the probe to keep everything in place. You apply the power, let the power off, and you keep the probe in place while everything cools. So when you move the probe away, nothing can move because everything's solid. So I think that's the way I'm going to do this. As I say, laminating the parts for the chassis, I laminated the pulley mount and I laminated the sides onto the etched overlays onto the sides, and it worked just so nicely. So I'm going to do that. Now, also, because there are 5 on here, there is a spare. So if for some reason, because these are small parts, the power is such from the resisting soldering unit that I destroy one, the first one, then I can always go back to the traditional iron for the others. But that's my plan. So there will be a card appearing to say that a few minutes later. It will probably be a lot more than a few minutes, but for you it won't. So stick with us, and hopefully across the entire length of this video we should end up with 4, hopefully 5 complete cranks with crank pins for the locomotive. Hi, welcome back. Tiny little bit more progress. So I have now cleaned up and tinned the backs of these 3 pieces. So they're going to stack up on top of each other. This one on this one on this one on this one. So I've tinned the back of these 3. As I say, I wasn't not going to try and do any of this on camera because I want to concentrate. Well, I suppose I might be able to do the resistance soldering. We'll see. But yeah, so these look okay now. As I say, I cleaned them up with a fiberglass brush and then a little bit of flux. Solder went on nicely. There are a few where I might have filled in the crank pin hole with the solder. Not a huge issue. I mean, not great, but not a huge issue because I need to tap them for the 16BA bolt anyway. So if necessary, I can put a tiny little drill through the hole and then tap it. As long as I don't fill in the top ones or the bottom ones, so I can get somewhere to start with. That should be okay. So next thing to do is remove these 4 bits from the etch, stack them up, cocktail sticks for the corners, and then I'm going to use the resistance soldering iron to seal everything together. It seems to be the easiest way, I think. I can just literally stack them all up and then push down in the middle of the axle hole with the resistance soldering iron while it heats up, and then nothing should move, and that should be all really nice. Apologies for the slightly wobbly handheld shot, but I just wanted to quickly show that I've got it all set up for the resistance soldering. So I've got a little board, drilled some holes in it, cocktail sticks through all 4 laminates, a little bit of foil underneath so that I can attach the wire to the foil, and that should allow me to put the probe in into the axle holes, press the foot pedal, and we should get a nice solid laminate. As I say, it might be overkill using this resistant soldering unit for this, but I think keeping everything lined up nicely, using the resistant soldering unit is easier, and I want to make sure that the laminates are really well soldered together. I don't want them risk them kind of flaking apart essentially once they're finished. So yeah, fingers crossed, and I should be back shortly with some hopefully soldered cranks. Right, that worked as expected. As I said, I had it this way up and just applied the resistance soldering unit to the top of the axle holes on each one, working my way across from one end to the other, all held in place with the cocktail sticks, and it just worked. It's not leaked lots of solder everywhere. The holes I've checked, I've taken a tiny little tapered reamer through the crank pin hole, not pushing it far enough to actually take any metal off, but through the crank pin hole. You can see that's one of them, but it fits through all 5. So while they may need opening ever so slightly to take the 16BA tap, they are actually still all holes. This is some of the 1.5mm steel rod that I used for the axles. It doesn't fit into any of the holes yet, but that's okay. It's not because they're flooded with solder, it's simply because the instructions say you need to ream them out. So yeah, that's what's up next. We'll be tapping and reaming them out. I'm not cutting them off the fret until all the crank pins are soldered in. Makes them a lot easier to hold on to and less likely to get lost if you do all the prep while it's still on the frame. So that's the next step, which maybe next or maybe another video, don't know yet. Wait around and see if it see what happens. Right, here we are, all done for finished cranks. As I say, nothing particularly complicated here. They were essentially just the holes were tapped for the crank pins. If I can get the camera to focus, you can see it. Holes were tapped for the crank pins screwed in and soldered solid again, while still all on that little on the little fret. I did the same thing for the soldering. I splashed a bit of flux around with them screwed in really tight, and then just touched through the central hole with the resistant soldering unit. Waited for it to all heat up, and jobs are good. Nice and solid crank with the pin in place. The hardest part was finding the right tap. So the 16BA tap is this one. Unfortunately, there's nothing on the tap that tells you what the size is, and it was in this box. Which is a whole bunch of other taps. I've no idea where its original box went. This is from a set of earplugs, the box, so I don't know quite how they're unlabeled. Anyway, I managed to find the right one eventually, and it just screwed nicely straight through the hole, and with no real problems. So I hadn't clogged up the holes with too much solder. The only other tricky bit was the fact that they're countersink screws, but the etch part doesn't have a countersink in it, so I had to find the right kind of size drill to be able to just drill slightly into the back, so that the screw would lie flush with the rest. Part of the problem being that means it cuts into the circular boss on the back. Not quite sure why it was designed that way, but anyway, that's what I've done. And they're all now flush. I did run a file across the backs while they were still in the etch, in the frame, just to ensure that the screw head and the back were as flush as they could be. But as you can see, you can still see the screw head, the notch in the screw head, so it didn't take much off, if anything. So yeah, they're all now nicely done, and I've got 4 of them. They all worked. I've cleaned up the edges a bit. Well, I say I cleaned up the edges. I've cleaned up where the tags were. So at either end of the, if you remember, they were joined to the fret. Oh, come on, camera. They were joined to the fret at the top and both ends. But I haven't had to clean up the sides, just where the tags were, which is another nice thing with the way the soldering worked. As I said, because I tinned the back and then just warmed it up, it's just flowed out nicely to the edges. I've not ended up with extra solder around the edges that I've had to clean up. So yeah, that's done. Not tricky, just takes lots of time and making sure you do each step nice and slowly and concentrate on what you're doing. Having said that, the resistance soldering iron was really helpful. Not quite sure how well it would have worked with a normal iron. I mean, I'm sure it would have worked, but I'm sure it would have probably been a longer, more finicky job and probably resulting in burnt fingers. Those little frames aren't huge, and to get the amount of heat in to laminate these things, I think I would probably have ended up with more heat in the frame, which also means if you're soldering one, you're unsoldering the next, which doesn't quite happen with the resistant soldering unit. But anyway, there we go. That's another step done. Hope you've enjoyed a bit more of a kind of broken down a video showing the different steps as I've worked my way through. Apologies I didn't do any of the actual work on camera, but as I say, given how small these things are, trying to work underneath the camera is a bit tricky. So yeah, I've done my best without actually doing that. So hope you've enjoyed that, and remember the subscribe button's down here if you want to make sure you don't miss the next video. When I'm not sure what I'm doing next, I haven't read the instructions. I will go read the instructions and find out, but yeah, subscribe button and then you won't miss it. Thanks for watching.